Okay. Let's see. I'll give you some even answers real quick. Number 6 should have been domain is all real numbers with x not equal to negative 1/2. Number 8 is going to be all real numbers with x less than or equal to 6.
Can you put that one over
Okay. Number 8, we've got the square root of 6 minus x. Well, what you got to remember with square roots or fourth roots or sixth roots or any even root is you can't take an even root of a negative number. That's when you get to the imaginary numbers. So, pretty much, I got to realize that, okay, whatever the heck's in here, this is called the argument of the radical, whatever's inside the radical has got to be positive, or at the very least 0. So, we can say to ourselves, this 6 minus x has got to be greater than or equal to 0. If it is, I'm okay, because then I can square root whatever that number might be. So I just solved this little guy. I can add the x over, or I could subtract the 6 and then divide by negative 1. I'll do that just to show you, it'll remind you something. If I subtract the 6 over, then what happens with an inequality if we divide by negative?
Switches.
Yeah, you change the direction of the inequality. So x has to be something less than or equal to 6. So just to make it more formal, my domain is going to be all real numbers such that x is less than or equal to 6. That's my domain. Sabrina, give me a number that's less than 6. 3. Okay. 6 minus 3 would be 3. Can I square root 3 and get an answer? Yeah, it works. Emily, give me a number bigger than 6, please. 13. Let's try 13. 6 minus 13 is going to be negative 7. Can I square root of negative 7? No, not in the real numbers. That's where you get in imaginaries. So it doesn't work. Because we said yesterday, there's 2 things that are going to screw up our domains for what we're going to be working with in the near future. Square rooting or even rooting a negative number, like here, and dividing by 0, like the most of the problems in this section. Okay. All right, looking at 12. Oh, goodness. 9, 30th, 3. Yeah. We're going to get 3 over 10y cubed. Okay. Now I'm going to put that up. And it simplifies relatively easily, but I want to talk about the exclusion. 18y squared over 60y to the 5th. Well, basically I can factor this. I don't have to write it, but I can factor it as 6 times 3 times y squared over 6 times 10 times y squared times y cubed. And we said we can use division to cancel multiplication. Because they're factors, I can divide like factors. 6 divided by 6 is 1, y squared divided by y squared is 1, and this is going to leave me with 3 over 10 y cubed. Now, here's a little nuance to this idea of listing the exclusions to the domain. When you look at the original up here, what number can y not be? JT? What number would screw this thing up and make it undefined?
0.
Yeah, if y was 0, 0 to the 5th is 0 times 60 is 0. That's going to make the whole denominator be 0. Y can't be 0 here, can it? When I look at my simplified version, can I still see that y can't be 0? Yeah, it's still apparent. I don't need to list that exclusion because it's sitting there staring me right in the face. So that one I don't have to list an exclusion on because it's still apparent. In the notes yesterday we said the exclusion to the domain is going to be from the factor that's no longer apparent. So if I factor it out and it's gone, like we had in that example that Sam did, we have to list that one as an exclusion. All right.
So you don't have to list y can't equal 0?
Right on this we don't have to, because I can still see it. You know, I might say, guess what? I'm wearing a white shirt today. Well, that'd be a silly thing to say because you can see it right there. You know, if I might have to tell you, oh, I wore a green one yesterday. Well, yeah, I might have to say that because you wouldn't know that if I didn't tell you. So, you know, if we take something like 2 over x minus 3 over 5 times x minus 3, well, I can see that x can't be 3 there. That would make the denominator 0 and mess it all up. But if I simplify it, and now when I look at that answer, just looking at that, I wouldn't know that x couldn't be 3. So I have to list it. If it's no longer apparent, then I have to list it. If it's still staring me right there in the face, I don't have to. It'd be redundant. All right. Can I do 13? Yes, ma'am. 3xy over xy plus x. All right. We got 3xy over xy plus x. All right, up top, I've got 3 factors. 3 times x times y. In the denominator, I got 2 terms. I can only divide like factors. So I've got to factor the numerator completely. It is, because they're all multiplied. And I've got to factor the denominator. Well, Alexis, what kind of factoring should I always look for first? Greatest common factor. Sabrina, look at that denominator and tell me what is the greatest common factor of those 2 terms?
X.
Absolutely, so we're going to factor an x out. I'm going to be left with y plus 1. Now I've got 2 factors of the denominator. One of them's x, and I see that x is also a factor of the numerator. So I can divide my like factors out, and then I can put my simplified answer. 3y over y plus 1. Now, what factor just got divided out? X. All right. What number for x would have made that whole denominator be 0? 0. So x couldn't be 0 here, could it? Well, here, there's an x in there. I wouldn't know that x couldn't be 0 unless I list it as an exclusion. Now, the fact that y can't be negative 1, well, that's staring me right in the face. I don't need to list that one. So that's our answer for, was it 13? Let me try to give you some evens here. Some of them are going to make me think a little bit. On 14, you should factor a y out, and you'll finish with 2y squared over x minus 1 with y not equal to 0.
2y squared?
No, I'm sorry, just 2y. Yeah. No, 2x squared. 2x squared in the numerator.
Where does the y come from?
That got divided out. 16, I'm going to factor the numerator by factoring a 9x out. I'll be left with x plus 1. The denominator, I'll factor a 2 out, and I'll be left with x plus 1. That x plus 1 is common, it divides out, and I'll be left with 9x over 2 with x not equal to negative 1. $18, I'm going to factor a negative 4 out of the numerator. Now, better show that one. 12 minus 4x over x minus 3. All right. Right now, that denominator is pretty well set. I can't do anything to that denominator. I sure like to find a factor in the numerator that looks just like that denominator. So that makes me think, oh, I'll factor a negative 4 out. Is that the one? No, it's not the one Sam did. Factoring a negative 4 out of the 12 leaves me a negative 3. Factoring negative 4 out of negative 4x leaves me with a positive x, and I use commutative property to rewrite it, just the order. Over x minus 3. Right now, Mr. Clayton, what number is multiplying this x minus 3 in the denominator? Oh, let's say Clayton? Landon. Is that the wrong name? You! What number is multiplying this x minus 3?
Negative 4.
No, that's the multiplying that one. What about this one down here?
3. 1.
What is it?
1.
Okay, thank you.
I'm guessing.
You're
I
guessing?
didn't help him.
Oh, I thought you did. He's looking over at you. Maybe he's wanting you to help
I was pressuring him.
him.
One?
Yeah, it's one. Yeah, it's just one times that stuff, right? So we need to kind of understand that that's just one, but if we need to write it, sure, okay. One times that. And now I can divide like factors, boom, and I just got -4/1 or -4. Michael, what number could x not be right here?
3.
3. So x can't be 3 here. That's the exclusion of Get the concept. Factor numerator completely, factor denominator completely, divide like factors. That's how we do every one of these. 20, numerator is going to factor to be x plus 5 times x minus 5. The denominator, I'll factor a -1 out, and I'll have x minus 5. X minus 5 will divide out, and you're going to get x plus 5 over -1. Which we could write that as -1 times x plus 5 with 1 and 2. That's the same thing. Because dividing by -1 and multiplying by -1 does the same thing. Or you could say, well, I'm going to divide -1 into both terms. -x minus 5. Either way, any of those are acceptable. And of course we need the exclusion that x can't be, what factor got divided out? X minus 5 got divided out. So x can't be what number? 5. Just 5. Now, we had that. We factored. A -1 out, and that gave me x minus 5. This is the factor that got divided out, x minus 5. That's the one that's no longer apparent in my answer. See, it's not there anymore. So whatever made that factor 0 is what I listed as the exclusion. X can't be 5. Now, looking here, Connor, what number's going to make that guy be 0?
-5.
-5. Well, do I need to list that as an exclusion too? Why not?
It's in the numerator.
It's in the numerator. Can I have halos in heaven?
Yep.
Yep. It's okay to have 0 in the numerator. That's not a problem at all. Right.
Did you move 16?
16? Okay. X squared plus x over something.
Plus 9.
And 2x plus 2. Alright. Right now, it's a temptation to maybe say, oh, I'll divide an x out of here and an x out of there. But I can't. Can't divide like terms. I only divide like factors.
It's not a 9x, it's just a 9.
My book has 9x.
One of these numbers.
Pardon? Yeah, I think it's 9x.
I wrote it down.
Okay. So, Alexis. When I want to simplify this guy, we said factor numerator completely and denominator completely. What kind of factoring can I do up the numerator? Right, always look for greatest common factor first. When you factor that 9x out, I'm going to get left from this term a factor of x, and from this term, 9x divided by 9x gives me 1. In the denominator, Anthony, what can I factor out?
2.
2, greatest common factor of 2, leaves me with an x plus a 1. And lo and behold, now I have a common factor. Because the x plus 1 is a multiple or a factor up top, and it's a multiple or a factor in the bottom, I can use division to cancel multiplication, because they're inverse operations. That's the whole logic of what we're doing. And this simplifies to be 9x over 2, or if you want to write it as 9 halves x, you certainly can. That's the same thing. And my exclusion is going to be, what, JT?
You're -2?
Pardon me?
-2?
Why -2? Let's put -2 in here. -2 times 2 is -4. -4 plus 2 is -2. Can I divide by -2?
Yeah.
Sure. That's not a problem. What factor got divided out?
2.
No, it didn't.
Like,
2 did not get divided out. Oh, I'm sorry, it got factored out, yeah.
Oh.
But in the whole problem, what did I cross out? What factor got factored
X
out?
plus 1.
X plus 1. What number would make that factor be 0?
1. Or -1.
-1. That's what I can't be. Because if x were -1 over here, and I'm dividing by 0. I can't do that. Okay, how far did we go? It's 22? One more, here we go. X squared plus 8x minus 20 over x squared plus 11x plus 10. Okay. There is a very, very real temptation that everybody feels every year. And they want to come in here and say, oh, there's an x squared, I'll just divide that out. Or they say, oh, I can divide 20 by 10, I'll divide that out. But those are terms. Terms are added or subtracted. You can't use division to cancel addition. So we cannot divide like terms. I can't say that enough because people keep making that mistake. So we got a factor. Up top, I'm going to look for greatest common factor first. Is there one, Anthony?
X.
Is it common to all three
Oh.
terms?
No.
No, so I can't do that. So I don't see anything common to all three. Alright? So of my other 6 types of factoring, which kind am I going to use, Evan?
Trinomial.
Trinomial. And Camila, trinomial always factors as the product of what?
2 binomials.
2 binomials. Alright, what's it going to be, Emily?
X plus 10 and then x minus 10.
X plus 10 times x minus 2, I agree. That works. Denominator, no GCF. It's also a trinomial. Factors as 2 binomials. And I'm going to get x plus 10 times x plus 1. That'll give me the 11x in the middle I needed. And now, because I have factors that are multiplied, I'm going to keep on saying it, you're going to get bored of me saying it, I know. I can divide like factors. You with me, JT?
Yeah.
You're staring off a Never Never Land back there. Alright. And then we're going to have x minus 2 over x plus 1 is my reduced form. Miss Sabrina, what factor got divided out?
X plus 10.
X plus 10. What value of x would have made that factor be 0?
-10.
So x can't be -10, can it? Is it still apparent here that x can't be -10? No, so I got to list it, don't I? And there is our answer. Better?
Is it going to be wrong if we do list
The other one?
X can't be?
If you said like if x can't be -10 or -1, well, it's not a lie, because x can't be -1 either, but it's not necessary. It's staring us right in the face. So if I ask you what's the domain for this function, the domain is all real numbers, x not equal to -10 or -1. Yeah, they're both excluded from the domain, but in terms of what do I write for my reduced fraction answer, this is all we got to write. And we certainly don't worry about the numerator, because the numerator can be 0. That's not a problem for us. Sometimes students will go up there and grab numbers too. Don't have to worry about that. So, think about what stumped you last night on this homework, what misconceptions you had, whatever I've said today to fix it. If you haven't written something down that reminds you of that, then do so now. Tonight you're going to do more of them. If you get this, if you just walk out of here and my words exit your brain, because your brain was halfway in Never Never Land, then that won't do. Okay. We are going to talk now. Let's go to multiplying rational expressions. I think I better stay in this area. I think it gets picked up by the camera. Multiplying rational expressions. Now, I'm going to come back, I'm going to put a big statement out here about what to do. So leave some space on your paper for that. But before I get into that and tell you exactly what we're going to do, we're going to go backwards in time and remember a little something that we all should know how to do anyway. See these rational expressions, like this guy right here. That's a rational expression, isn't it? It's just a fancy word of saying, well, I just pointed that and said, what is that? What would you tell me it is? It's division, okay, yeah. What else might you call it?
Fraction.
It's a fraction. It's a fraction. Our fractions happen to have, you know, expressions of x and variables in it, because we're in algebra class. But it's a fraction. The same rules that apply to fraction that you learned back in the 4th grade, they apply to this stuff. And this is why I always fuss about the teacher in 6th grade that sticks a calculator in her hand and said, here, use that ABC button to do fractions. Because you don't learn how to do the work, and then you can't do this stuff. So when you guys have children, don't let them have a calculator until they get in high school. You'll be doing them a great, great favor. All right. Or limit what they get to use it on. Now, so let's take this idea of multiplying rational expressions back to multiplying fractions. Let's take something like 14/25, and let's multiply that by 30 over, oh, let's see. No, I know. Ooh, that's 63. There you go. Lost. Right. Now, we want to multiply this guy. When you multiply fractions, I mean, we multiply numerator times numerator, denominator times denominator, right? Okay. Woo-wee, 14 times 30. That's going to be 420. Okay. $25 times 63. Boy, I don't know. Help me out, Sabrina. You got your calculator there. That's a big one, isn't it? I can probably figure it out. It's something 75.
1,575.
Okay, 1,575. Okay. Let us cheat a little bit and grab a calculator for that. But now, you got to reduce this. You can't use a calculator. Okay. Everybody has to do that reduction in 10 seconds, or you have to give me $20. Go. Shh, you can't do it. Point made. It's going to be tough, isn't it? Well, kind of. Those are big numbers. It'd be a little hard to reduce that now that they've gotten big, right? And here's the point. We don't want to multiply them out and get these great big numerators and great big denominators and then try and simplify it. Wouldn't it have been so much nicer if we simplified it first? Yeah, I think so. So here's the idea. This is the overriding concept of what we're going to do to simplify rational expressions or multiply rational expressions. We're going to simplify them before we multiply them. So What are factors of 14? 2 and 7. Okay, let's factor that guy. All right. What are factors of 25? 5 and 5, okay. And to that I'm going to multiply, let's see, factors of 30?
5, 2, and 3.
We need sophomores with the last name beginning M through P. Sophomores, M through P.
5 times 2 times 3, Sam says. He's got it down to the prime factors, that's right, essentially 10 times 3. All right. Factors of 63?
3, 3, and 7.
Okay, 9 times 7 is 63, so that 9 could be 3 times 3 times 7. We've got it factored completely, down to its prime factors. Boy, that phrase of factored completely sounds familiar, doesn't it? We just did that last section. We factored polynomials completely down to their prime polynomial factors. Same idea. Now, when I multiply two rational expressions, or two fractions, we said a moment ago, it's numerator times numerator, denominator times denominator, right? Well, look, this is just one great big multiplied numerator and one great big multiplied denominator. So is it going to be okay to use division to cancel out a factor from the left side and the right side? Yeah, because it's really just one great big numerator, one great big denominator. So I can divide the 7s out. What else will divide out? 5, okay, divide a 5 out. Anything else?
3.
A 3. This 3 will divide one of those 3s. And there's nothing else top and bottom, is there? So let's see, let's multiply what's left over. Up top we got 10 over, no, it's not 10, where's my brain going? That's 4 over 15. Hey. So apparently, my big hard one over there that would have been tough for you guys to earn your 20 bucks from, to reduce it in 10 seconds, that's easily reducible. It's 4/15. If you punch that big fraction in your calculator and you punch 4/15 in your calculator, you'll get the same decimal. Very cool. So that idea is how we're going to reduce our algebraic rational expressions. So, let's come up with a phrase up here. Up top, what did we do to the numerators to get it to this format? Excuse me? Simplified how? Yeah, we simplified completely, but what kind of simplification did we do? Starts with F. We factored, yeah. So we factored the numerator completely. What do we do to the denominator? Factor the denominator completely. Once we got them all factored, then what do we do with that red pen? Crossed out, but what mathematically did we do? Canceled, but divided. We divided like factors. Boom. That's it. So that's what we're going to do. With multiplying rational expressions, we're going to factor the numerator, numerators, and denominators completely. I'll underline completely because it's important that we take it all the way down to its prime factors. And then say divide any like factors and list exclusions to the domain. Just like we did with homework last night. And I'll put in parentheses here that are no longer apparent. So let's take a look on here. make sure that I'm picking up that screen with my camera here. Oh, yeah. Looks good. All right. Now, when I want to multiply these together, which is my goal, just like the last problem, remember we multiplied the numerators together, we got that great big number? We multiplied the denominators together, we got that really, really big number? If we tried to simplify then, it was hard, right? Well, if I go to the trouble to multiply these together now, well, heck fire. If I multiply this trinomial times that binomial, I'm going to get some great big x to the fourth polynomial down here. And if I multiply those numerators together, I'll get some great big x to the fourth polynomial up top. But then I'd still have to reduce it, wouldn't I? And to reduce it, I'd have to factor it. And boy, to get a big multiple term fourth degree polynomial and factor that, I might be able to do it with grouping. But maybe it's going to have like 5 terms in it and I can't use grouping. That'd be hard to do. So again, point being, we want to factor it first, simplify it before we multiply it. Oh, that's a good phrase. Simplify before you multiply. That kind of rhymes. Alright. Well, we'll get t-shirts made up more into school. Simplify before you multiply. Alright. Okay, so to simplify rational expressions, we said we're going to factor numerators and denominators completely. So, Mr. Anthony, top left numerator, or the left numerator, top's redundant, isn't it? How may I factor that, sir?
3 times 1. What do you mean?
I want you to factor 3x minus 15 for me. What do you always look for first?
Common factors.
What is it?
3.
Uh-huh.
So 3 then x minus 5.
There you go. Precisely. Alright, numerator on the right-hand side. What kind of factor are we going to use, Michael? X squared, x cubed minus 8.
Difference of cubes.
Difference of cubes, factors is the product of what, Tate?
A binomial times a trinomial.
A binomial times a trinomial, absolutely. And we remember those phrases because they help us, don't they? Alright. Sabrina, you want this one? X cubed minus 8? What goes in the binomial?
No, I'm doing it a different way.
What do you mean?
I'll explain it.
Are you factoring a different piece of it or something?
No. Do this.
Let's see if we get the same answer.
I should
What are you
X-
doing? Yeah, no. I know what I see what you're doing. But you still got subtraction going on between there. So that's one term and that's another term. That's one term and that's another term. You cannot divide terms. I grant you x is a factor here and here, but it's not a factor of the whole denominator. So I can't do that. Very tempting, but no. Alright. JT, difference of cubes.
X minus 2, and then it'd be x squared, it would be plus 2x, and then plus 4.
Good. Yep. Get that pattern down. Alright. Denominator on the left side, Miss Kim, what kind of factoring will I use there?
Just trying to do that.
Trinomial, and trinomials factor how? As the product of? 2 binomials. Alright. I'm going to keep on making you guys say those phrases so it sticks in your brain until you're 80. Alright. Left hand side, factors how, Camila?
X minus 2, x plus 5.
Very good. And the denominator on the right hand side, Tate, how's that going to factor?
X minus 5 times x plus 5.
What kind of factoring did you just do, sir?
Difference of squares.
Difference of squares, we got 2 binomial conjugates, okay. Are we factored completely? Yep, everything's to its prime factors. This trinomial we said will never factor more from the difference of cubes. All right, now we look and see if there's anything we can divide out. What do you see, Alexis? Anything common to both numerators and denominators?
X minus 5,
X minus 5, okay, here and there.
and X minus 2.
X minus 2, here and here. That's it, isn't it? Okay? Now, when I go to express my final answer, I don't have to multiply all that stuff back together. Factored form is simplest form. So, what I'll just do for my final answer is I'll write 3 times the quantity x squared plus 2x plus 4 over the x plus 5 times x plus 5. I can express that as x plus 5 quantity squared. I'm gonna list my exclusions right below because I think right about here is as far as my camera's going. So my exclusions are gonna be x not equal to, what do you think, Connor?
2 and 5,
2 and 5. Why did you choose those?
because in the denominators it was x minus 2 and x minus 5 that we removed.
That we removed. Those are the ones that got divided out. Those are the ones that are no longer apparent. I can't tell it unless I list it. What other number is excluded from the domain that we didn't have to list? Negative 5. Yeah. Negative 5, x can't be negative 5 also, but it's staring me right in the face. I don't need to list that one. That's multiplying rational expressions. It's just an extension of yesterday's work. Instead of just reducing one rational expression, we're kind of doing 2 at the same time. Knocking it out. That's it. Guess we better quit. All right. I'm going to write your assignment up on the front so it'll be on the camera, and then I'll put it over on the side too. We're going to be on page 48. And we did 5 through 8, that's done. Let's get 23 through 27. And let's get 35 through 38. That'll work. Still practicing and using all these good factoring skills.